meeting this year. And I have an honored guest is Dr. Tai Sik Lee, who is the president of the Korean Federation of Science and Technology Societies. Earlier today, he gave a presentation about space exploration to space settlement. So our conversation is going to be going into, what does it mean to settle space?
Oh, that is a hard one. But we are the alien on the Earth.
And that's us, right?
Yeah, you are alien too.
Yeah.
Just to the Earth.
Yes.
So we are settlement on the Earth, but now we are talking about the settlement for space.
Yeah.
So we should be ready for that.
With so much of the, we have the space, I feel like space is just always in the news now with SpaceX and NASA kind of have a reemergence with rockets are able to re-land, so when I think about space settlement before, it used to feel so far away, super sci-fi, but we're a lot closer to it now than before, correct?
So before the Elon Musk, usually they make the airplane like rocket, fly to the moon and then leave it there and come back. Mm-hmm. But the Elon Musk now, he can use it like the airplane. Yeah. So now we can go to the moon and then come back by the airplane. Mm-hmm. So that means we need not airport, but spaceport.
Okay. And when we think about a spaceport then, there's conversations of colonizing, I don't know, colonizing is the right word, but at least going to Mars and then settling on the moon. What is a spaceport and what does that look like? Okay,
first of all, can you imagine we call the rover as an automobile for the moon and Mars, and that is only 1 kilometer per hour without the road. So, and we make the spaceport on the moon, we need the berms, embankment for the 6 meter, 8 meter high, because touchdown and then flume and then fly the soil and the rocks into the habitat. Mm-hmm. So we need the civil infrastructure and then road and then habitat. So we need many infrastructure for the moon and Mars for the settlement.
And are these conversations that are happening at your institute, or what is the conversation to, you're thinking about space settlement? What, aside from infrastructure, what are other facets that we have to think about when we're thinking about settling a different place?
Also, surviving in the space, we need the water, and then we need the oxygen, we need the food, and that is we call the settlement for that.
Mm-hmm. Mm. Why settle in space? Why can't we just stay here, vibing on Earth?
That's a good question. You can read the Noah's Ark in Bible, and he prepared a ship for the settlement, each pairs of animals. Mm-hmm. Like that, if we have that problem on the Earth, we need to move somewhere. There is a moon is only 3 days, and then Mars is 8 months, but still we can go there. If we have a problem on the Earth. Mm-hmm. Have you seen the movie The Core?
I have not.
Okay, core means that if you have the problem and then the atmosphere is disappeared, then we are dead.
Yeah.
So we need to prepare for the shelter for people.
Yeah. Okay, so that's, I feel like I have 3 different questions going on. But I'm curious then, so you're saying it's kind of inevitable that there's going to be a point where we're going to have to leave Earth because of the conditions here, that we're going to have to go have a second home or a second base, almost like WALL-E, like the movie. Have you seen WALL-E, Pixar? Yeah. So do you think that's are we talking a couple years, 1,000 years? I guess when do you think we would have to have this escape mission?
Before that, I showed
or can we have his slides on the?
Yeah,
piece?
So it's Paul was drawing in the 120 years ago. Mm-hmm. And then so he wrote the French, the left side top, and then where do we come from? Mm-hmm. And then what are we? Mm-hmm. And then the third one is very important. Where are we going? Mm-hmm. Mm-hmm. So there is a past, now, and then future. We need to prepare.
Okay.
And then second interesting, this is a Korean pop singer, and she's only 30 years old, and then she is singing about the old cloud. You know how far is it from here? Old cloud is 50,000 astronomical units. 1 AU means that from us to the sun is 150 million kilometers. So multiplied by the 50,000 is far. But as you know that we have the Voyager 1, 2 flying to the deep space in 1977, still going on. So after 300 years, that Voyager can go to the old cloud. That is very long. But I told you, Moon is only 3 days, Mars only 8 months. The Mars is a problem because when you want to come back to the Earth, that is 8 months and then 6 months wait, and then another 8 months. So we need 22 months. So it's far. But Mars has atmosphere. So small oxygen, but a lot of CO2, and we want to make the terraforming for that. And Moon is without atmosphere, but NASA sent the L-Cross to hit the Moon, and then they found the ice on the soil. So that means you can make the water, and that means you can make the oxygen. So you can go and safely and stay.
I guess, I don't know if this is a controversial question maybe, but I feel like right now the people that have access to space are the ones that have a lot of money. And so when we think about an escape route or settling into being alien species in different planets that are no longer Earth, is that only limited to the billionaires or those that can invest in a plane ticket or whatever the escape route is? Like, is this going to be available to just the regular person that is able to have access to this?
Right now, we need about $100,000 per person. But have you heard about space elevator?
No, I feel like I have, but not quite sure. Yeah.
It's 100,000 kilometers. We can go up there with only $375 per person. Then we can make it.
Yeah.
Right? But the problem is that from the Earth to the Moon, right now is instead $2 million. Right now, $1.2 million per kilogram. So that is expensive. That is only one way. Yeah.
Okay.
Yeah. So $1.2 million. You have 40 kilograms, and then multiplied by the 1.2. You need a lot of money.
Where is this money going to come from? Like, is it like self-funded? Like, I have to pay my ticket there, or is this like going to be some kind of like government initiative? Like, what? Like, I guess if we know it's so expensive, why worth investing in it?
You need the money.
Yeah.
But when the venture company make that called Mars One to the Mars, and first of all, 25,000 people applied, one-way ticket. They don't want to come back. But the final is 800 people, only one Asian, and then final 250 no Asian, all European or the American. But still they want to go to like the Columbus. Yeah.
I guess. Okay, so can you give us a little glimpse of like what you spoke about earlier in your session in terms of like where does the ethics come into play in terms of how are we cross collaborating with different nations, or who is involved in, I don't know if gatekeeping of like who can go in space and who doesn't.
Okay. This is myself, and then you cannot read it, my biography. But the last part at the first line, Korea team was winning out of the 77 teams, the Habitat for the Mars by the 3D printer. As Korean team was won, and that is very important. So we are ready for. So you ask question why we should go, and then we have the human survival, like the Noah's Ark, and also resource is very important, like the helium-3 on the moon. If we bring the 1 ton of the helium-3, and then we can have that all energy for the 1 year for the Earth. that is important. The third one is scientific exploration. So we can go to the deep space. I told you about the Voyager 1 and 2. They started in 1977, still flying. They expected 200 years more, and then arrived at the Oort cloud. So this one is space travel technology, and then the habitat design, and then life support system. It's very important for the life. First of all, water. Second is oxygen, and then food. And we need to make it as a smart farm and for the food. So this is my 3D printer, very big, 4 meter by 4 meter by 3 meters. And we can make it a house only $3,000 per person. So you can see it.
Like a space pod, or like what do you mean? Like what?
Yeah, you will see it. That is my team. And I had an interview with the NASA TV, and then I called I can make it a house for people, $3,000, and he was surprising. But not like the American, not like the Korean, but it's like Africa and Bangladesh. But Bangladesh wants to have $1,000 instead of $3,000 per one house.
Yeah.
This is 48 hours printing, and 2 meter high, and then you can put the roof for the solar cell energy, and then we can make it a house for the 4 people.
All right, pause real quick. Okay, so is the goal then, okay, we can go different routes in this. I guess when thinking of like, okay, if one of the things we do for space settlements to have a place to stay, is the goal to like, would this be part of like the cargo that will be on a rocket that will like launch to like settle there, or is
no, we can just bring the 3D printer. We will use, that's a good question. We will use that in situ resource utilization is very important because I told you $1.2 million per kilogram from Earth to the moon. That means that every cheap materials going to the moon, and then like the diamond, the price. So we should use in situ resource. So we, after Apollo 11 to the Apollo 18, they brought 380 kilograms of the moon soil and rocks, and they analyzed it. That is the same as that volcano basalt in the sea, not the land. 99.5 is the same. So in 2002, I made the lunar soil, copy lunar soil. We call the lunar simulant. That is, I was invited by the NASA, and we made it. So Korea is the 5th country to make the lunar simulant. And then after 2 years, I developed the lunar concrete. But concrete, no cement, no aggregate, no sand, no water. It's only the lunar soil and then binder. We can make it. That's why we had that house with that lunar soil and then the binders. It's a very strong, stronger than concrete, also concrete by 2 times. So quicker. Usually the cement concrete in us is 28 days for the strengthen. But that is just we print it and then we got the strength.
And so when you say in situ, that means like we're gonna like, so if say we're already like on the moon, we have a 3D printer there that is using the moon soil to like use that as like the filament to do the 3D printing. Is that what the goal is then?
Yes, but the problem is that radiation and also the asteroid come down, and that is maybe we should start on the cave life first, like the 2,000 years ago. But that, yeah, final is that we can make it. We will see the design later.
Okay. Are you going to share anything else, or?
Okay. Oh, this is Buzz Aldrin is my mentor, and then Neil Armstrong had passed away. But these 2 gentlemen were pilots during the Korean War. So after come back from the moon, and they had a trip on all the United States, and the first country is Korea. They come. Even Buzz, remember when he was a pilot, he remembered the address in Korea.
When we think about, all right. So when we think about, okay, so what are our current barriers right now before, aside from just kind of like having more information of like the environments that we're going to be in to settle these different types of satellites or planets? What are the current barriers, at least in your research, to make that accessible or make that a reality?
Okay, first of all, the problem is the vacuum. On the moon, no atmosphere. So this one is a vacuum chamber. Usually physician and the chemistry wants that clean vacuum chamber, but we want the dirty vacuum chamber because we want to put the soil, lunar soil, and also dust coming out. So for this one, it's 10 minus 6 tall without the soil. With the soil, 10 minus 4 is very important. We can make the vacuum only 2 days, usually 30 days. So this one is 6 meter diameters and 4 meter long. And Korea, I was president of KICT, Korean Institute of Construction Technology. I made this vacuum chamber is the largest one, still in the largest one. And then that means we can put the 3D printer there, and then we can make the house, and also we can test everything on the environment of the moon and Mars.
Can any of this technology that we're thinking about developing to settle Earth be beneficial within our own Earth?
Yeah, sure. You will see. Because this one is also an environment for the Earth and also Mars. And you can see the environment tree and everything. Before that, I have 8 different technologies. Korea developed 5 technologies already. So we are ready for the habitation on the moon and Mars. And this one is your answer. So you can make the farm there, agriculture industry, and still America is a big land, but like Singapore, they want to food farm, but they want to make the building for the farm. That we can make it that technology from the space. And also, we have the Jeju Island. We have we got on the volcano basalt. We can farm it. That is another good to the plant. That also that we can use it because whenever we have the solar power plant, we have the cloud and the rain, we cannot use it. But to the space, you can, above the cloud, you can make the electricity and then come to the Earth. There is another solution for the energy for the Earth.
All right. Wow, this sounds, well, thank you so much for sharing at least a small snippet of what your talk was earlier. We have time for at least like 1 or 2 questions if anyone in the audience wants to ask Dr. Tai Sik Lee. Anybody wants? Anybody? All right. I guess as we wrap up, what are you most optimistic about in terms of, where your technology or where your innovation
First of all,
is going?
you use it microwave oven at home. Everybody.
Yeah.
That is technology from the space.
Yes.
And then you are using the sunglasses. That is also technology for the space. So we can use it. First of all, habitat. We need that robot or the 3D printer. So we can make that life sciences there. And also we can make the AI. Your topic, all the area of AI. So AI can support the construction processes automation. And also intelligent building management system already we are using it, but that is for the space too. So last and sustainable operation is very important. Like we don't have that atmosphere, so we use the space dome, and then we can put everything on the buildings and the people, and then farm.
Yeah, but it sounds like, yeah, thank you just for giving us insight in terms of like the different types of pillars of infrastructure that has to be in place in order to space settlement to be a reality in our, yeah, pretty near future. Hopefully not. But, and in the sake of just like, I'm going to be left behind. But, but no, this is really interesting and really innovating. And thank you so much for your time.
Thank you so much.
Awesome.
Thank you so much.
Is our next guest Martha here by chance? Martha, okay, cool, awesome.
meet
All
you.
right, thank you so
Thank
much.
you so much,
It was
Stephanie.
nice meeting you.
I'm done.
Yeah.